Hello students, welcome back to our channel. Students, in this video we are going to study two very important types of functions in mathematics, which are exponential functions and logarithmic functions. So let's start with exponential functions first. To understand the concept of exponential functions, let us see this graph. On this graph we have drawn five different graphs of five different functions, which is x, y equal to x, y equal to x square, y equal to x cube, and y equal to x to the power 4. So here we will see that if the power of, suppose this is the function fx equal to x to the power n. So if the value of n is increasing, then this function fx or y, we can call it by any name, this function is growing more rapidly, right? This is y equal to x, right? Which means the power of x is 1. So this is the function. Now if the power of x becomes 2, then it becomes more steep, and if the power of x is 3 from 2, it becomes more steep, and then it becomes more steep. And that is obvious because if we compare two functions, suppose we are comparing x square and x cube, right? We are comparing fx equal to x square and fx equal to x cube. Now this function, let us call this function f1 and f2, and let us call this function as f3 according to the power of n, and we will call this fn. Okay, now if we put 1 in this function, we are going to get the value 1, and if we put 1 in this function, again we are going to get the value 1. Okay, now if we put 2 in this function, if we put 2 in place of x in this function, then it is 2 raised to power 2, and 2 raised to power 2 is 4. And if we put 2 in this function, that means 2 raised to power 3, and that is 8. So we can see clearly when x changes from 1 to 2, when x changes from 1 to 2, then the value of function changes from 1 to 4 in this case. But in this case, when x changes from 1 to 2, then the value changes from 1 to 8. So this change is more, right? So obviously when the power is more, then the value is going to become as the greater value as compared to the function with the lesser power, right? Now if we take, suppose let us take one more example. If we take f4, which is x to the power 4. Now if you put 1 here, you will get 1, but for 2 you will get 16. So it is increasing more rapidly, it is growing more rapidly, right? That's why the graphs are like this. For the same change in x, change in y will be more when the power of x is more. So graph is shifting towards the y axis, right? Okay, but let us talk about the exponential functions. Now we want to see, is there any function which grows more rapidly than this polynomial function? Obviously all these functions are polynomial functions, right? And polynomial functions we have already studied in class 9th, in 10th, in 11th, in 12th also. So we are familiar with polynomial functions. So this is the behavior of a polynomial function, the graph of a polynomial function when we increase the exponent. So all these x to the power 4, x to the power 3, x to the power 2, x to the power 1, or x to the power 5, or any value of x, all these will give 1 at x equal to 1. So they all meet at x equal to 1. And when they cross 1, when they cross x equal to 1, they changes their sides. For example, when x was smaller than 1, then this x to the power 4 was below x to the power 3, but for values greater than 1 it is above x to the power 3, right? This was the graph of x to the power 3 na. This is the graph of x to the power 3. Yeah. This is the graph of x to the power 3. So for the values of x less than 1, x to the power 4 wala graph was below the graph of x to the power 3, but for the values of x greater than 1, x to the power 4 is above x to the power 3, because if the value of x is less than 1, like 1 by 2, so at f equal to 1 by 2 in f3 we are going to get this answer 1 by 2 raised to power 1 by 2 raised to power 3, which is 1 by 8. But for f4, for 1 by 2 we are going to get 1 by 2 raised to power 4, that is 1 by 16, which is smaller than 1 by 8. So for the values less than 1, the function with higher exponent is going to give you a lesser value, but for values greater than 1, the function with higher exponent is going to give you larger values. So that's why the shapes of these graphs are like this. But now we are interested in finding if there is any other function which changes more rapidly than the polynomial function. Then the answer is yes, there is another function. Suppose let us take the example of fx equal to 10 raised to power x, and such type of functions are called exponential functions. When the exponent is x, right? When the base is a natural number or a real number and the exponent is x, such kind of functions are called exponential functions. We can clearly show that this is greater than the polynomial function, or it is increasing more rapidly than the polynomial function for suppose larger values of this function. Let us say, what is f of 100x? F of 100 is x raised to power 100. Now if we find the value of this function at say x equal to 1000, then we are going to get this, which is 10 raised to power 300. Now if we put x as 1000 in this function, that is in exponential function, if we put x as 1000, we are going to get 10 to the power 1000, which is obviously, this one is obviously greater than this. So this function, exponential function, will increase more rapidly, right? So this is the graph of exponential function, which is steeper than the any other graph of the polynomial function x raised to power n. This graph cuts the y-axis at y equal to 1, because when you put x as 0 in this function, then 10 raised to power 0, you are going to get 1, right? If the base was not 10, suppose it was some other number, even then also you are going to get the answer as 1, because any number raised to power 0 is always 1. So this is always going to come as 1, right? So this function, the graph of exponential function, always cuts the y-axis at y equal to 1. And for the negative values of x, this is going to decrease, because if x is negative, suppose we put x as -2 in this function, so ten raised to power -2 is 1 upon 100, which is 0.01, right? So it is going to decrease, and it will never touch x-axis on the left hand side, because it becomes 0 only when the x is -infinity. When you put x as -infinity, then it will be 1 upon 10 raised to power infinity, which is 0. So it will touch the x-axis only when x is -infinity, so which cannot be shown on the graph. So we will just make this function like this, make this graph like this, and we will not touch this graph with negative x-axis, right? So this is exponential function, any number raised to power x. any real number raised to power x. So general form of exponential function is simply a raised to power x. So 10 raised to power x is called 10 raised to power x is called common exponential function. Common exponential function, and e raised to power x is called the natural exponential function, right? What is e? E is a constant in mathematics. E raised to power x is a series 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on. The short name of this series is e raised to power x. So the value of e is what? You are going to get the value of e when you will put x as 1 on left hand side and right hand side. So if you will put x as 1 on the right hand side, after solving this you will get this value equal to 2.781, right? So e raised to power x is called natural exponential function, 10 raised to power x is called common exponential function, or any number raised to power x is your exponential function. So what are the properties of exponential function? Domain of the exponential function is R. You can put any real number, right, as we have discussed. Range of the exponential function is the set of all positive real numbers. We can see that this graph is not going below the x-axis. That is, the value of y is never going to come as negative, because negative value comes only when the negative sign is here, and the negative sign will never come here even when the x is negative. Since when x is negative, then that will go into the denominator now, and we will get a small positive value. So this is not going to ever come as a negative value. So its range is what? Its range is the set of all positive real numbers, right? So everything that we have discussed is written on this, and you can pause the screen to read the properties, but we have already discussed all these properties. Now let's come to the logarithmic functions. What are logarithmic functions? If we have written as, suppose we all know that 5 raised to power 2 is 25, right? And we know that if we want to shift this exponent on the other side, then this becomes a power which is the reciprocal of this number. If 2 goes on that side, then the power of 25 becomes 1 by 2. So we all know that what happens when exponent goes from one side to the other side. We all know this. But what happens when exponent remains on the same side and this base is shifted on the other side? For such cases, logarithmic function is required. So if we shift 5 on that side, if we shift, suppose we have 5 raised to power 2 equal to 25, and we are keeping 2 on the same side, on this side, and we are shifting 5 on that side. So we will write log base 5 25. So this is the meaning of logarithm, which says if we are writing, let's write it in general terms. If we are writing log base a b equal to c, then we are saying that a should be raised to power c to get b, right? Just hide this. And what is the meaning of this? It is saying that to what power 5 should be raised to get 25. So 5 should be raised to power 2 to get 25. So log base 525 is 2. Log base 525 is 2, right? So for any base a, this function y equal to log base a x, this function is called the logarithmic function. right? Now for few bases you can see the graph of logarithmic function here. We have drawn the graph of log base 10, log base e and log base 2. And if when the base is decreasing, then the logarithmic function is becoming less and less steeper as compared to the other graphs, right? And all these graphs meet at x equal to 1 because for any base log a 1 is always 0, because to what power this number should be raised to get 1? Obviously 0. We have to raise this a to 0, only then we will get 1. So log 1 is 0. Base doesn't matter. 2 raised to power 0 is 1, e raised to power 0 is 1, 10 raised to power 0 is 1. So every graph of log is going to meet the x-axis at x equal to 1, right? So these are the graphs of logarithmic function. There are some very important properties of logarithmic functions that you are going to use in class 12th differentiation. Number 1, we are not going to prove these properties, or we can prove these properties using examples. There are other proofs also which are beyond the scope of the book that you are following, that is NCERT class 12. So we are not going into the proofs, but we can see the examples on the basis of these properties, right? So for any base, but first see that this is log base ex is also written as ln x, which is read as natural log x, or in maths book it is just written as log x. When the base is not present, you will assume that the base is e, right? Like when no number is written on the square root, then we assume that it is the square root, right? If it is some other root, then the number is written, but if nothing is mentioned here, we take it as a square root. So that is by default. So when no number is written here, we will consider it as a natural log, that is the log which has base e. E is the number that we have just discussed about, right? Okay, so what is the first property? First property is that for any base a, log 1 is always 0. We have discussed this property. Second property, if this number and this number are same, then the answer is obviously going to be 1, because to what power a should be raised to get a? Obviously 1. Number 3, log, most important property, log any base a to the power b is b log a. Log a to the power b is equal to b log a, right? For example, let us say for base 5 we have suppose 625. So we know that 5 must be raised to power 4 to get 625. So this can be solved like this only. If we write 625 as 5 raised to power 4, and then this 4 will come here, then this becomes 4 log base 5, and here also 5. So log 5 is 1, so answer will be 4, right? Okay. Next property number 4, log AB is log A plus log B, right? And this for any base, this is true, and this can also be proved very easily using examples. Log A raised to power B is log A minus log B. So let us take the example of first property first. Suppose we have to find log base 5 25 into suppose 25, right? and we know the answer is 4 because 5 should be raised to 4 to get this. So the answer is 4. But if we use this property and separate these two, again the answer will be 4 because this is going to be 2, this is going to be 2, 2 plus 2 is 4. And similarly, you can prove yourself this property also using an example. Now, next property, if we change these two numbers, then we have to take the reciprocal of the log, right? And last property that we have to use in class 12th very rarely, that is the introduction of the new base, but this will be very important to remember some formulae of differentiation. Suppose we have to introduce a new base c. So for that we will write, for log base ab, we will write log base c b divided by log base c, the original base a. Right? So these were the properties of exponential and logarithmic functions. These functions are very important to solve exercises 5.3, 5.4, 5.5 from NCERT that we are going to discuss in next lectures. I'll meet you in those lectures. Till then, all the very best.